All right, so in the remainder of this course, you'll be implementing your CPU core. And this is the visualization that you'll have available for doing that. And what we're looking at here is, in green here is the instruction memory. This is where your program is stored. So the instruction memory is holding on to these binary values that are interpreted as instructions that your machine is going to execute. These instructions will be loaded into your CPU core. So here we're loading an add immediate instruction into our CPU core that's going to produce a value in the register X12, and we can see that value has been written here. So this add instruction is adding 0 from X0 to an immediate value provided by the instruction itself of 10. You can see that value here in the instruction in binary form, and it's shown here in the decode logic as a decimal 10. So we add 10 to 0, we produce a value of 10 in register X12, and we write that into the register file. So the register file is holding on to values that our CPU core operates on. If we continue to step, we do another add immediate instruction that's writing to X13, and this one's doing 0 plus 1, produces a 1. And now we have an add instruction, again 1 plus 0 is 1. And what this program is actually doing, this is the program that you're going to use to initially develop your CPU core. And then after you develop the core to run this program in Chapter 4, in Chapter 5 you'll complete your RISC-V core and execute all instructions. And this program is adding values from 1 to 9. It's summing the values from 1 to 9. And the first time through we're processing the value of 1. I believe that's in register 14 is our running summation. And register 13 here is keeping track of our, actually I'm not sure, let me check. Yeah, that's right. Register 13 is our loop counter. So we've just executed a branch. I'm going to step backward here to the branch. The branch instruction is taking us back up to the beginning of our loop. And each iteration of our loop is summing the next value in the sequence. So if I continue executing these instructions, you'll see that the value in X14, register 14, is holding on to this sum. So it's currently added values 1 plus 2. Now it's going to do plus 3 to get 6. And if I step 3 more times, plus 4 to get 10, and then 15. And then 21, and so on. So we're continuing to iterate in this loop until we've summed all values up to 10. R12 is holding on to the value of 10, the constant value of 10, so that we can do, I guess, 9 iterations of our loop. And the branch instruction compares our loop count with that value of 10. Once we reach 10, the branch less than will no longer branch, it will fall through. So if I continue to step, we will now fall through the branch, meaning continue execution sequentially and complete our program. So that's the program you're going to start with, and we'll talk about all the aspects of the CPU core, the instruction memory, the instruction decoder, the register file in more detail as you implement them. After you implement this subset CPU core that executes this program, you will implement all of the instructions that you'll do in the course and running a different test program that executes each instruction. And at this stage you've also added the DMEM, the data memory, which we can see now here. And we're executing this program, which is next going to execute a store instruction, which is going to write a value to the memory, and then the load, which is going to read that value from the memory. So this is the framework that you're going to be working with, the visualization. Certainly as you're developing your CPU core, also this diagram, logic diagram, is going to become increasingly complete. And you'll see, of course, more and more signals in the waveform. All right, so next we'll talk about the setup that you're going to start with to get you on your way.